All right, ladies and gentlemen, what we're going to be doing today is we're going to continue to talk about magnetic fields. Today we're going to be talking about magnetic fields produced by current running through a wire. So we've talked about two of our right-hand rules. We've looked at the second right-hand rule and the third right-hand rule, and today we'll be looking at the first right-hand rule. I know we're kind of doing this backwards in terms of the order of them, but that's okay. So you'll go through this slide presentation. Your assignment for the day is going to be, so you have your exit ticket. Your assignment is actually going to be for day number 11 and 12, which is today and tomorrow. And you're only going to be doing the first page of that assignment. The second page is a lab page for a lab that we'll be doing tomorrow. So if you really want to get a jump start on it, you're more than welcome to, but you will not be able to actually turn it in until tomorrow. All right. So today we're going to determine the direction and magnitude of a magnetic field on a wire. Just kind of as a recap as to what we've talked about already. We talked about particles traveling through a magnetic field and the force they experience. That was using that the right-hand rule where your thumb is velocity. So that would actually be your, in the video I had you guys watch, that was actually your third right-hand rule. And then we also talked about current running through a wire, and then it creates its own magnetic field. And we talked about when you place a wire within a magnetic field, what kind of force that wire experiences, and that was using our second right-hand rule. And then today we're going to actually calculate the magnetic field that a wire produces, and you'll solve for the direction and force of that magnetic field. All right, so here's that video. You guys have probably watched this video already. This video is just it's kind of just a magnetism overall recap. It goes through the three laws. You can give it a watch again if you want to. I just think it's a really good video in terms of electromagnetism in general. We are going to talk about forces on parallel wires is a lot of the problems we deal with when we're talking about these kind of problems and solving for the magnetic field on a wire. So when we are dealing with, we always deal with parallel wires, and it's just going to be a matter of if those wires are going to, if the current is traveling in the same direction or the opposite direction, and that's what these arrows are representing. So we have current running one way, current running the other way, and then for this second one we have current running in the same direction for both of them. Well, within a wire, using our first right-hand rule, where we have your thumb being the current, and then all four of your fingers curl around one way or the other, that will tell you which way the magnetic field is going. All right, now it's kind of hard to show on here because I'm on a 2D screen, but if I have, let's see if I can try to represent this here. And there's a better video right down here if you want to click on it. If I look at this blue wire on the far left, and I point my thumb up, well, what's going to be happening is the magnetic field on the left side of this is going to be coming out at me. So if I were to create a bunch of lines, the magnetic field is coming out at me. These are just magnetic field lines. So that magnetic field is coming out at me because that's the way my fingers curl. They point towards me. Well, then on the other side of that wire, they're going away from me. That magnetic field is going away from me. And the exact opposite would be true for the one going in the opposite direction. Please watch this video, though, down here at the bottom. You can watch that. You can either watch that now or you can watch it in a little bit after I kind of explain the equation. But that video, he does a really good job of explaining parallel wires and how they're either going to repel or attract one another depending on if the currents are going in the same direction or if they're going in opposite directions. Okay? So, looking at the magnetic field that a wire actually creates. we are going to use this equation. Remember, B is our magnetic field. So B is magnetic field. And don't forget, that is measured in Teslas. And then we have this funky looking mu naught, mu sub naught. And what that is it is the permeability of free space. When we say free space, we're just talking about a vacuum, so like outer space. It's 4 pi times 10 to the negative 7th, and we measure it in Tesla's meters per amps. If you look this up on Google, if you were to look this up, I believe you end up getting like 1.25 times 10 to the negative 6th or something like that. But that's if you were to actually go ahead and calculate it out as using 4 pi. I just like using 4 pi because I think plugging into your calculator is a little bit easier and it's a little bit more accurate too. Okay. You won't have to worry so much about the label when we're using this, so don't get too hung up on trying to memorize that label. All right, so the reason we're going to use this permeability of free space is we're going to basically treat it as all the magnetic fields that we're dealing with, we're going to treat it as if we were in a vacuum. Obviously, we're not, but just for simplicity's sake, we're always going to treat it as if we're in a vacuum. So taking a look at using this first right-hand rule. All right, now I have an X and a dot over here. And what that is representing is two wires. Okay, now we're actually looking at it from is if you were to be looking at those wires, is if you like cut them and you're looking right down. I don't know how to describe that. You're not looking at the wires from this angle where you can actually see them. It's almost like you take it and turn those 90 degrees and now you're looking at the ends of them. Okay, so we're dealing with two wires that we have an X here, so that's going into the page, and we have a dot over here, and that is coming out of the page at us. Okay, so this over here, what I drew over here, is actually what it would look like if you were to be looking at those wires from the top view. You'd have one going one way and one going the other way, and they are running parallel with each other. We're always going to assume that they are running parallel with each other. All right, so the question, or a question that you might get for this, it says, at a point midway between the wires, what is the direction and magnitude of the magnetic field for the two wires if they are 10 centimeters apart? Okay. Now I guess I didn't really finish explaining this equation over here. I hope you know what the rest of these represent. Don't forget I, or current, is represented. We use amps for that, and then we're dividing it by 2 pi r, and r is just going to be your radius, and in this case, your radius for this problem over here, it is 10 centimeters. However, we're talking about a point that is midway between these two wires, so we're going to be talking about a point right in the middle. So you're not actually going to use 10 centimeters. You're actually going to want to use 5 centimeters because that's where you're calculating the magnetic field. Now, if I were asking you to solve for the magnetic field of maybe this wire on this wire, then you would use the 10 centimeters. But we're looking at a point right in between there, so we're going to use 5 centimeters. Okay, so let's go ahead and change up colors a little bit. Let's go ahead and start to solve this. So the first thing I want to know is what I'm going to figure out which way is the magnetic field for each of these actually going. Erase this over here. So when I use the right-hand rule that I'm going to use here is going to be my first right-hand rule. So I'm going to take my thumb, and you're just going to point it in either out of the page or into the page, and that's going to determine which way the magnetic field is going around that wire. So for this first one, for this 5 amp wire, it is going into the page. So therefore, since your thumb is pointing into the page, your four fingers curl around in this clockwise direction. And then for the 7 amp one, you're going to point your thumb right at yourself because it is coming out of the page. And then your fingers are going to curl in the counterclockwise direction. Okay, so both the magnetic fields are pointing in the downward direction in the center where this particle would be, or where this midway point would be. So essentially what we're going to end up having, the magnetic field is going to be overall pointing downward. We know that because they're both pointing downward. Now, if I were to say, let's treat this one, let's just say we're going to treat this as, let's say they're both dots. Okay, so let's say they're both going, coming out of the page. Well, now what's going to happen is that's going to change things a little bit, because now we would have where both of these are going counterclockwise. So now we have this 5 amp wire, the field would be going up, and for the 7 amp wire, the field would be going down. So we would actually have to take the difference of those fields to find that net field. Okay, but let's go back to, I'm going to set that problem up like we had it before. So we have clockwise, counterclockwise. And now let's go ahead and plug in our information for this. All right, so I actually have to figure out the magnetic field for each one. So I'm going to go ahead and use this equation, B equals 4 pi times 10 to the negative 7th times, and keep in mind here, when we go to plug all this information in, we are given centimeters here. You do not want it in centimeters. You always want it in meters. So when I go to plug this in, I'm going to have divided by 2 pi, and then I'm going to multiply it by, we're not using 10 though. Remember, we're halfway, we're at a point halfway between, so we're actually going to use 0.05, and then we calculate that out. And we should end up getting 0.00. I want to make sure I have the correct amount of zeros. 0.0002 Teslas. Okay, go ahead and solve for the 7 amp one. I'll pause the video and you can go ahead and solve that yourself. Okay, so I actually went ahead and I made this a little bit easier to look at, so hopefully the colors help. So we have, hopefully you found for the 7 amp wire that it is 0.000028 Teslas. And remember, that is also in the downward direction. Okay, so we want to know, at that midway point, what is the direction of the magnetic field for the 2 wires? So basically what we're doing here is we're solving for that net magnetic field. So since they are both pointing in that downward direction, all we are going to do is we are just going to end up adding them together. So I will have 0.00002 Teslas in the downward direction and 0.000028 Teslas in the downward direction. So our grand total magnetic field will actually end up being 0.00048 Teslas. I use purple. You like that? Because red and blue are purple. In the downward direction. So I would just say, I would just add the word down to that. Okay, I want to give you one other example, just as if, just because, let's say, for instance, like I was talking about before, let's say now instead, I'm just going to treat this one. I'm going to change this up a little bit. So like, let's say this one is now also coming out of the page. Okay, well, if that's coming out of the page, if they're both coming out of the page, well, now I'm going to have both of these going counterclockwise. So what that's going to create is it's going to create two different fields. Your 5 amp field's going up and your 7 amp field is going down. All right. So if that were the case, then what we would have to do is we'd have to actually take the difference of these two, because now we would have this 0.00002 Teslas up and this 0.000028 Teslas in the downward direction. So when you take the difference of those two, what you would actually end up with is you would end up with 0.00008 Teslas in the downward direction. Okay. So just keep that in mind as you're going through your assignment. Okay. Don't forget, your assignment for the day is going to be to just do the first page of the day 11 and 12 assignment. The second page is a lab that we'll be doing tomorrow. And then your exit ticket will have some questions from your day, from that first page. And I'm going to do kind of what I did before. I'm actually going to block out some of the answers on the answer key. So if you see those answers blocked out, that's why. It's because that's actually going to be your exit ticket questions. Okay. Let me know if you have any questions via email or private comment. Have a great day.